Today's lesson is on trigonometry, which is just the study of the relationships involving lengths and angles of triangles. So today we're going to learn about 3 different trigonometry functions. The first trigonometry function that we're going to learn about is called the sine. The second is called the cosine. And the third is called the tangent. And each one of these functions relates to a right triangle, comparing the measures of side lengths to angle measures. So if we're going to talk about one angle in particular, in this case we're going to talk about angle A, the sine of angle A, so we would write that as the abbreviation for the word sine is just S-I-N. I know it looks like sin, but it's actually pronounced sine. So the sine of angle A is going to be equal to the relationship between 2 side lengths. The side opposite, so the side opposite an angle, if you look directly across, so that's going to be the opposite side over the hypotenuse. The hypotenuse is always the longest side, the hypotenuse. So in this case, side A over side C. The next trig function is the cosine, and that's abbreviated COS. So the cosine of angle A is going to equal the adjacent side. Now the adjacent side is the side that is directly next to the angle, but is not the hypotenuse. So the adjacent over the hypotenuse. So the cosine of angle A is B over C. And the tangent. So that's the third of the 3 functions we're talking about today, and that's abbreviated tan. So the tangent of angle A is going to be equal to the opposite side over the adjacent side. In other words, A over B. So these are our trig functions, and there is actually a mnemonic device you can use to remember that. So we take the first letter S, O, H, so we could say so, and then C, A, H, ka, and tangent, so T, O, A. SOHCAHTOA. If you can remember this, it should help you remember how to write the ratios and which function goes with which side, which relationship between the sides. So those are our 3 functions. Now I want to give you a couple of examples on how to apply our trig functions. So here's an example, and I'm going to give us a triangle. This time I'll give some measurements to the sides. So let's call this triangle GRT with side lengths 8, 15, and 17. We are dealing just with right triangles, and you'll notice this is a Pythagorean triple. If you do a squared plus b squared, you'll get c squared. So the sine of t. Remember, so that's OH, SOH, so opposite over hypotenuse. So that's going to be, here's angle T, opposite over hypotenuse, that's 8 over 17. Cosine. So the cosine for this example, remember cosine, ca, AH, adjacent over hypotenuse. So the adjacent, remember that's the one directly next to the angle, but not the hypotenuse. So the adjacent is 15 and the hypotenuse is 17. And the tangent. Remember that's TOA, so that's the opposite over adjacent. And that is equal to 8 over 15. So we'll do a couple more examples. This time we'll include some angle measures. So that was it. Let's call that example 1. Example 2 then. We'll take part A here. We'll call this A. Here's a right triangle. And let's call this angle 45 degrees. Let's call this side W, and the length of the hypotenuse is 17. If I want to find the length of W, I need to decide which trig function would be best to use in order to calculate that. So, in terms of this angle here, I have the opposite side involved and I have the hypotenuse involved. So, which trig function relates the opposite side and the hypotenuse? Well, if we go back up, opposite and a hypotenuse, that's a sine. So we can say the sine of 54 equals the opposite over the hypotenuse. In other words, the sine of 54 equals 17, nope, the opposite is W, sorry, equals W over 17. Next step to solving this is to multiply both sides by 17, trying to get W by itself. So we multiply both sides by 17. And then we need a calculator to solve. So 17 times the sine of 54 is going to be equal to, rounding to the nearest tenth, 13.8. And you just enter that into your calculator as 17. You could just type in the trig function sine and then 54, just as it looks. Part B. So again, we're going to try and find angle W. This time given the angle here as 28 degrees. You can see we have the opposite and we have the adjacent. So we need to think about which trig function relates the opposite and the adjacent. Well, that's the tangent, TOA, opposite and adjacent. So I can say the tangent of 28 equals 1.0 divided by W. Now this time, I need to first get the W out from underneath the fraction, and then divide both sides by this tangent of 28 to get W by itself. So I have W tangent 28 equals 1.0. Divide both sides by the tangent of 28. and we get W equals 1.9. So trigonometry actually has a lot of uses when we talk about measuring the distance to maybe the top of a really tall building, or the distance to the moon. These are the types of things where trigonometry comes in handy and is used on a regular basis. Let's do one more example. Part C to this example 2. So we've got triangle here with an angle of 33 degrees. Here's W. Here's the hypotenuse of 4.5. So it looks like we have the adjacent, so that's right next to, and the hypotenuse. So adjacent and hypotenuse, that looks like cosine, adjacent and hypotenuse. So I can say the cosine of 33 degrees equals W over 4.5. For this one, we just need to multiply both sides by 4.5 and enter it into my calculator. So 4.5 times the cosine of 33 is 3.8. All right, let's do example 3. This time I'm going to try and determine the measure of the angle. So I have a triangle here, triangle BHX. Here's my right angle. Side lengths are 6 and 10. And I want to try and find the measure of angle X. How can I find the measure of angle X using these two sides? Well, I have to decide on a trig function. You can see here I have the opposite side and the hypotenuse. So which trig function deals with opposite and hypotenuse? Well, that's the sine, right? The mnemonic that we use is SOH, S-O-H. So I can write this out as the sine of X. We don't know what angle X the measure is, equals 6 over 10. Now, just like all of the functions that we work with in our previous math experience have an inverse, such as addition has an inverse function of subtraction, multiplication has the inverse function of division, and if we square a number, the inverse would be to square root. In the same way, the inverse function for our trig functions, it's really straightforward. It's called the inverse sine. So the inverse sine, in order to get rid of, as we say in algebra, in order to get rid of this sine function, we take the inverse of that, and so we can get X by itself if we take the inverse sine of 6/10. And so if you enter that into your calculator, the inverse sine of 6/10, you will get 68, rounding to the nearest degree. So X equals 68 degrees. So that was part A. We'll try one more just like that, part B. So this is triangle XMN. And again, I want to find the measure of angle X. And I'm given, so this is the angle we're looking for. And I'm given the adjacent, and the hypotenuse. So adjacent and hypotenuse, that's the cosine. So I can say the cosine of x equals 15, that's the adjacent, over 20, that's the hypotenuse. Similar to the inverse sine, we could take the inverse cosine. If we wrote it all out, it might look something like this. The inverse cosine of the cosine of x equals the inverse cosine of 15 over 20. It is understood. We don't need to write all of that. We can just keep in mind, okay, the inverse cosine cancels this out, and we're left with just x. And we take the inverse cosine of 15/20. And we get 41. Approximately. I'm sorry, up here I had that wrong. So up here, when you calculate that, you would get about 37 for the measure of angle x. So those are our two examples about inverse trig functions. From here, you should be able to do your Math Excel assignment, and as always, come and see me if you have questions.